A single structure could hold more life than our entire galaxy. This is the Alderson Disk, a concept so vast it redefines possibility. By the end, you will grasp a megastructure with more surface area than every star system combined. We will uncover the physics that could allow a sun to be caged at its center and explore what happens to a society with no horizon. What does true mastery over a universe look like? The sheer size of such a structure defies our everyday logic. To call it a planet would be like calling an ocean a puddle. The Alderson Disk is not a world you orbit. It is the world you stand upon, a flat plane of engineered materials stretching further than your mind can truly picture. Think of our own solar system, with its planets tracing graceful circles around the sun. Now, erase those circles. Fill in the entire space from the orbit of Mars out to the orbit of Jupiter with solid ground. That is the basic footprint of the disk, a single continuous surface with the sun fixed perfectly at the center of the whole, like a jewel in a pendant. The star does not set here. It hangs eternally in the middle of the sky, a permanent noon for the entire inner rim, casting light and warmth across an area so large it makes every planet, moon, and asteroid humanity has ever known seem like insignificant specks of dust. This is the core proposal from scientist Dan Alderson, a thought experiment that asks what happens when engineering ambition escapes the gravity well of a single world and decides to build the floor of the universe itself. The disk is not a ring like those in famous stories which are narrow bands circling a star. This is a full record, a solid platter millions of miles thick to provide enough structural depth and internal space. Its two sides, the sun facing top and bottom, could each be engineered for life, meaning the total habitable area isn't just double that of Earth. It is millions upon millions of times greater. We are no longer talking about colonizing a new frontier. We are talking about constructing the entire concept of home from scratch, on a scale where geography loses all meaning, and a single structure contains more room for civilization than the Milky Way contains stars. This redefines world from a celestial accident to a deliberate, architected plane of existence. To grasp the scale, we must abandon all familiar comparisons. Our galaxy is a swirling disk of light, home to hundreds of billions of suns. Each of those stars could, in theory, host its own family of planets. Yet if you gathered every single world, every moon, every rocky surface from every one of those systems, their combined habitable area would be a mere footnote. The Alderson Disk is not competing with planets. It is competing with the very galaxy that contains them, with an inner edge set at the comfortable distance of Earth's orbit and an outer rim reaching out toward where Jupiter travels. This single engineered plane creates a staggering amount of real estate. The mathematics are almost incomprehensible. The total surface area, counting both the sunlit top and the engineered bottom, could exceed 100 trillion times the entire area of our planet. Think of that number for a moment, 100 trillion. For every single square foot of land and sea on Earth, the disk offers 100 trillion more. This means one civilization on one project could manufacture more living space than every naturally occurring, potentially habitable planet in the Milky Way combined. This single fact sends ripples through our deepest questions about life in the universe. We look up at the silent stars and wonder, where is everybody? This is known as the Fermi paradox, but if a species could build an Alderson disk, the paradox changes. Why would they spread thinly across the galaxy, struggling with the immense voids between stars, when they could instead turn their own solar system into a paradise of unimaginable abundance? Cosmic real estate is no longer about finding new worlds. It becomes about forging your own on a canvas so vast it makes the search for other planets seem quaint. The ambition is not just to fill a galaxy, but to replace its very purpose. But such a paradise requires a captive sun. At the very heart of the disk, suspended perfectly in that central void, is the star itself. This is not a power plant we built, but a natural furnace we have caged. The entire structure depends on this delicate, terrifying balance, where the sun's immense gravitational pull is exactly countered by the sheer mass of the disk encircling it. The star becomes a fixed jewel in a celestial setting, its light and heat radiating out to warm the inner faces of this artificial world. This solves the eternal problem of energy for a civilization of this scale, but it introduces an engineering challenge of almost mythical proportions. The sun cannot be allowed to drift, not even a fraction. Any wobble, any shift toward the inner rim would spell disaster on a scale we can barely articulate. The material holding it in place, whether through gravitational counterweights or some form of active stabilization we cannot yet conceive, would need to be stronger than the fundamental forces trying to pull the star into the disk. It is the ultimate act of cosmic balance, a star in a bottle, maintained by a technology that treats gravity itself as a variable to be tuned. The reward for achieving this impossible feat is a climate of eternal stability. For hundreds of millions of miles inward from the outer edge, the sun-facing side of the disk would bask in perpetual, gentle noon. There are no seasons here, no axial tilts, no orbital winters. The light is constant, the temperature regulated by nothing more than your distance from that central fire. This creates a Goldilocks zone not as a narrow band around a star, but as a vast, continuous plain. On Earth, the line between desert and tundra is drawn by latitude and orbit. On the disk, it is drawn simply by how far you choose to walk. The inner regions would be warm, bright gardenlands, while the territories farther out would gradually cool into more temperate zones, all under the same unmoving sun. This is celestial plumbing of the highest order, where a civilization does not adapt to its environment, but seizes control of the very star that gives it life, designing a forever spring across a surface larger than a galaxy. This eternal stability comes at a strange price, one that rewrites the very laws of gravity as we know them. On a planet, down is always toward the center, a simple pull into the heart of the world. But on the Alderson disk, down becomes a matter of perspective, defined not by a spherical core, but by the sheer mass of the plane beneath your feet. The disk's own incredible bulk, millions of miles thick, would generate its own gravitational field, pulling perpendicular to its surface. For someone standing on the sunlit topside, gravity pulls them firmly toward the ground, just as we experience. But for a civilization engineered on the disk's opposite face, the bottom side, gravity would pull them toward that surface too. They would be standing comfortably on what the top dwellers would call the ceiling. Both populations would look up into the same central void and see the same star shining down, or rather, shining up from the hole between them. It is a dizzying inversion, a world where the sky is not above you, but is instead a ring of distant landscape curving up and over your head, with a sun suspended in the center of it all. Walking on the ceiling of the world would feel perfectly normal to them, their entire reality flipped relative to ours, yet governed by the same consistent, local pull toward the massive plane they call home. This creates a profound and beautiful paradox where two entire cultures could thrive back to back, separated only by the thickness of the disk structure, each living in a perpetual noon under the same star, yet forever upside down from the other's point of view. Their shared sky is not the cosmos, but each other's distant, curving lands, a constant reminder of the engineered nature of their entire existence. This beautiful paradox of shared skies rests upon an impossible foundation. The most immediate and absolute barrier to building an Alderson disk is not ambition or energy, but the very stuff it must be made from. No known or theorized substance in our universe possesses the strength required. Think of the strongest materials we can dream of: carbon nanotubes woven into cables, sheets of flawless graphene, or the dense metallic hydrogen theorized to exist at the heart of gas giants. All of them would fail instantly and catastrophically under the titanic stresses involved, spanning distances measured in hundreds of millions of miles while resisting the relentless pull of a central star. They would behave less like steel and more like wet paper, crumpling and tearing under their own unimaginable weight. The disk demands a material with near-infinite tensile strength, something that does not just bend the rules of physics but rewrites them entirely. We enter the realm of speculative physics, where engineers must become architects of reality itself. One theoretical candidate is something called stabilized neutronium, the impossibly dense material that makes up neutron stars. A single teaspoon of it would weigh as much as a mountain range on Earth. To fashion entire continents, entire worlds, from such a substance is a feat bordering on alchemy, turning the collapsed core of a dead star into the bedrock of a new one. Even more fantastical are concepts like cosmic strings, hypothetical flaws in the fabric of space-time left over from the universe's birth, threads of pure energy thinner than an atom yet stronger than gravity. Building with cosmic strings would be less like masonry and more like stitching the cosmos together, using the universe's own seams as structural support. This moves us from supermaterials into the domain of what science fiction often calls unobtainium, a placeholder term for a substance with exactly the properties you need, regardless of whether the laws of nature allow it. The true construction material for an Alderson disk might not be a substance at all, but a manipulation of the underlying fields of reality. Imagine if gravity could be locally cancelled or inverted, if space-time could be woven into a rigid lattice, or if the strong nuclear force could be scaled up to planetary dimensions. This is no longer engineering, it is reality editing, a level of mastery over nature that treats physics as a set of parameters to be adjusted. The civilization that builds a disk isn't just working with the universe, it is working on the universe, performing cosmic-scale surgery to create a stable plane where one should not, by any natural law, be able to exist. The materials are only the first impossible requirement. The second is energy, a currency spent on a scale that makes all of human history look like a single spark. Constructing the Alderson disk is not a project, it is the project, an undertaking that would consume the total output of stars for time frames longer than our species has existed. We must think in terms of stellar engineering, where moving a planet is a trivial first step. The raw mass needed, enough to forge a solid plane hundreds of millions of miles across, would require the complete disassembly of not just the rocky worlds in a solar system, but the gas giants and every asteroid and comet as well. A civilization would become a cosmic recycler on the grandest possible stage, breaking down entire worlds to their elemental atoms and reassembling them into the smooth, engineered plane of the disk. This process alone demands energy beyond any conventional source. One theoretical method involves a fleet of self-replicating machines, often called von Neumann probes. These would be robotic swarms that land on an asteroid, use its material to build copies of themselves, and then send those copies out to the next resource. Over millions of years, such a swarm could systematically dismantle every planetary body in a system, a slow, inexorable wave of deconstruction paving the way for construction. The energy to power this millennia-long operation would likely come from the star itself, captured by a Dyson swarm of orbiting collectors that siphon its total light output for ages. Some concepts go even further, suggesting the need to tap into the vacuum energy of space itself, or to place small black holes at strategic points, feeding them matter to convert into pure, usable power via their glowing accretion disks. This is the energy budget of gods, not engineers. It transforms the very idea of a megaproject, we are no longer discussing building a bridge or a city. This is the deliberate, patient restructuring of a star system into a single, architected habitat, a process of cosmic alchemy that turns random, scattered matter into a perfect, ordered plane for life. The timescale is not human but galactic. The civilization that begins this work understands it will not see the end, not for thousands of generations. It is a commitment etched into the fabric of their future, a promise made to descendants they will never meet, living on a world they will only ever dream of. This mastery over matter and energy leads to a quiet, profound shift in perspective. The very idea of a planet, of a world, becomes a relic. For a civilization capable of building an Alderson disk, living on a natural sphere like Earth would feel profoundly limiting, even primitive. Why confine your entire species to a thin, fragile layer of biosphere clinging to a ball of rock, when you could instead inhabit a continent that literally has no end? A planet offers a single, closed ecosystem, a delicate balance constantly threatened by its own geology and orbital mechanics. The disk offers the opposite, an open plane of total control. On this engineered surface, ecosystems are not found, they are allocated. Climates are not endured, they are dialed in with precision. You could have a rainforest biome the size of 1,000 Earths, bordered by a desert of equal scale, each maintained in perfect, eternal stability by the unmoving sun and the disk's own internal systems. Geography is not a force to be conquered, but a feature to be designed, with mountain ranges placed for aesthetic beauty or resource distribution, and seas shaped into geometric patterns visible from orbit. This represents the ultimate triumph over the natural environment. It is not about adapting to a world, but about retiring the concept of a world altogether in favor of something far grander, a manufactured universe contained within a single, flawless structure. The planet becomes a pebble, a charming artifact of a younger, more constrained era, while the disk becomes the new definition of home, a canvas so vast it finally matches the scope of a truly advanced civilization's ambition. This engineered perfection would birth a social landscape stranger than any alien world. How do you govern a continent that has no edge? The traditional model of a nation-state, defined by borders and a central capital, dissolves on a surface this vast. Even traveling at the speed of light, a signal could take years to cross from the inner rim to the outer darkness. A single, unified government becomes a practical impossibility, a voice shouting into a canyon so wide the echo never returns. Instead, the disk would naturally fragment into a tapestry of millions, perhaps billions, of autonomous zones, each region separated by gulfs of distance that make Earth's oceans seem like puddles, would develop in profound isolation. Over centuries, these communities could drift into cultures as distinct from one another as we are from ancient civilizations, developing unique languages, philosophies, and even concepts of reality shaped by their specific place under the eternal sun. A city-state basking in the perpetual warmth near the inner rim would have a world you built on abundance and light, while a settlement in the cooler, dimmer far reaches might develop a culture centered on resilience and the careful stewardship of energy. They might forget they are part of the same structure, their shared sky a distant, unattainable ring rather than a unifying dome. This isn't a global village, it is a universe of villages, each an island on an endless plain. This radical decentralization forces a complete rethinking of economics. With a literal infinity of building space and the total matter of a solar system to work with, the concept of scarcity evaporates. Land is not a limited resource, it is the default condition of existence. Basic materials forged from the disassembled planets could be as ubiquitous as air. In such an environment, the driving forces of our own economy's competition for resources, property value, territorial expansion become meaningless. This could pave the way for a true post-scarcity civilization, where technology meets every physical need and human endeavor turns toward art, exploration, and pure intellectual pursuit. Yet this utopian vision has a shadow. The one resource that is not infinite is proximity to the central sun. The inner rim enjoys perpetual, ideal warmth, while the outer regions exist in a permanent, deepening twilight. This creates a natural gradient of desirability, a cosmic beachfront property versus the hinterlands. It is easy to imagine a new, brutal form of social stratification emerging, not based on wealth or birth, but on zip code defined by astronomy. An elite class might secure the prime inner territories, living in engineered paradises, while others are consigned to the colder, darker outskirts, reliant on complex technology to simulate the light and warmth their neighbors take for granted. The very structure that eliminates material scarcity could enshrine a new, immutable hierarchy based on celestial geography. The disk, designed as the ultimate liberation from a single world, might instead become a stage for social divisions written in light and shadow, a permanent map of privilege and exclusion etched across a surface larger than a galaxy. But the most profound change would be written across the heavens themselves. For the people of the disk, the night sky is a memory, replaced forever by the architecture of their home. In one direction, the central sun hangs in eternal, fixed noon, a brilliant and unmoving anchor. Turn around, and you are faced with the most staggering sight imaginable, the opposite face of the disk itself, curving up and over you to form the entire dome of the sky. This is not a sky of stars, but a sky of land. The distant, sunlit landscapes of the far side arch overhead, a band of glowing terrain separated by the gulf of the central void. At night, when that distant side faces its own period of darkness, it might glitter with the lights of countless cities, a sprawling, inverted constellation of civilization itself. The true cosmos, the glittering tapestry of alien suns and swirling galaxies, is completely hidden. It is blocked by the sheer, overwhelming bulk of the disk's own structure, a shell of engineered world that wraps entirely around the sun. The inhabitants live inside a celestial terrarium, a bubble of reality where the only astronomical objects are their own star and their own world, mirrored above them. This creates a form of cosmic isolation so complete it reshapes the soul of a species. Generations would be born, live, and pass on within this sheltered technological womb, their myths and sciences built entirely around a two-object universe, a sun and a shell. The concept of other stars would be pure speculation, a philosopher's dream with no evidence in the observed heavens. To see the true universe, one would have to journey to the very outer edge of the disk, to a place where the solid sky finally ends and the infinite blackness of space becomes visible. Or perhaps they would build great observational towers, rising high above the atmosphere to peek over the curve of their world, creating portals to a reality they never knew existed. The moment of that discovery would be the greatest revolution in thought possible. It would be like the people of a vast, endless plain, who believed their plain was all of creation, suddenly finding a crack in the ground that revealed an ocean vaster than their entire world. Their entire cosmology, their understanding of their place in existence, would shatter and reform in an instant. The disk, designed as the ultimate act of creation, would have also built the ultimate cage, not of walls but of perspective. The universe outside would become the final and most unimaginable frontier. The sky is no longer a mystery but a blueprint. With the true cosmos hidden, the focus of a disk civilization turns entirely inward to the ultimate act of creation, the engineering of nature itself. On a planet, climate is a global, chaotic system, a delicate balance of ocean currents, atmospheric pressure, and solar angles. On the Alderson disk, it is a design choice, a variable to be set with the precision of a thermostat. The very geography is not discovered, it is drafted. engineers could sculpt mountain ranges not to rival the Himalayas, but to span distances greater than the orbit of Mercury, their peaks serving as climate barriers or simply as monuments to aesthetic ambition. They could excavate shallow, continent-sized seas to exact depths, controlling evaporation rates and marine ecosystems from the ground up. Weather is not a force to be forecast, but a feature to be programmed. Vast orbital mirrors, positioned in the space between the disk faces, could angle additional sunlight to darker regions or cast cooling shadows. Atmospheric processors might gently guide prevailing winds, ensuring that a rainforest zone receives its daily rain with clockwork regularity, while a neighboring desert remains perpetually dry under the same eternal sun. This is total environmental mastery, the transformation of climate from a planetary condition into a local utility. The result is a world of zones, a vast mosaic of biomass laid out across the endless plain. Imagine concentric rings like a giant tree stump viewed from above. Nearest the inner rim, a band of perpetual tropical warmth, thousands of miles deep, a single, unbroken garden. Farther out, a ring of temperate forests and grasslands, then cooler steppes, and finally, at the very outer edges, vast expanses of Arctic tundra, all under the same central star, their temperature dictated solely by distance. Or perhaps the design is more artistic, a patchwork quilt of environments, a square of jungle the size of Asia placed beside a desert of equal scale, each maintained in perfect, isolated equilibrium. This power allows for more than just control, it allows for preservation and invention. Every Earth-like biome, every endangered ecosystem from our own fragile world, could be recreated here in a protected, eternal form. But why stop at recreating Earth? With such command over the fundamental parameters of life, entirely new biologies could be pioneered. What does a forest look like under a redder sun, even if that red light is filtered through a lens? What creatures might evolve in a low-gravity zone engineered into a floating archipelago? The disk becomes a living laboratory the size of a galaxy, where the question is no longer what life can adapt to, but what life we can imagine into being. This is the final step in a civilization's journey, moving from inhabitants of a world to the architects of their own reality, painting with continents and programming the wind, all on a canvas where the only limit is the scope of their own creativity. This total environmental control faces its greatest challenge not from the ground, but from the sky. A sun fixed eternally at the center creates a world forever divided into two stark halves, one bathed in endless, brilliant noon, the other plunged into an abyssal, starless night. For life that evolved under a rhythmic cycle of light and dark, this static condition would be profoundly alien, even hostile. Our own biology, from the sleep cycles in our brains to the growth patterns of plants, is tuned to a turning world. To make the disk truly livable across its vast expanse, its architects would need to invent not just geography but time itself. They would need to build a mechanical sunrise. The solution is a second layer of megastructures, a celestial clockwork orbiting between the sun and the disk's surface. Imagine vast concentric rings, each one a slender ribbon of material wider than planetary orbits, set at different distances from the star. These would not be solid bands, but intricate lattices supporting billions of individual panels, each one a controllable shade or mirror. Their purpose is simple yet staggering: to cast a moving shadow. By carefully rotating these rings and angling their panels, engineers could create a precise simulation of a day-night cycle. A wave of darkness would sweep across the sunlit face of the disk, a manufactured sunset traveling at thousands of miles per hour, followed hours later by a corresponding dawn as the shadow passes. On the night side, the opposite could occur, with orbiting mirrors reflecting slivers of sunlight to create a dim, artificial day. The scale of this undertaking is a symphony of moving parts on a solar system stage. Each shading ring is a megastructure in its own right, requiring its own stabilization, its own power, and its own flawless coordination with the others. A failure in this system would not mean a cloudy day. It could condemn entire continental regions to decades of unintended midnight or unending glare. The circadian rhythm of every forest, every city, every living thing on that portion of the disk would depend on the silent, perfect choreography of these orbital giants. This adds a breathtaking layer of necessary complexity. The disk is not a static painting, it is a dynamic engine, and its most fundamental gift to life, the reliable turn of day into night, is the product of relentless, precise maintenance. It is the ultimate testament to the structure's artificial heart. Here, nature's most dependable cycle is not a given, but a calculated achievement, a beautiful, fragile illusion of a turning world maintained by minds that stopped accepting the universe as they found it. Even the most perfect machine has its rough edges. On the Alderson disk, these edges are not mere borders, they are entire worlds unto themselves, realms of extremity that frame the engineered paradise. The inner rim, the very lip of the vast central hole, exists in a state of perpetual inferno. Here you stand at the edge of a star. The sunlight is not merely bright, it is a physical force, an endless torrent of radiation and heat that would vaporize any known material in moments. For a civilization that has mastered stellar engineering, this is not a wasteland but a powerhouse. This scorching frontier would likely become the disk's primary industrial heart, a place where the raw, unfiltered fury of the sun is harnessed. Imagine continent-sized arrays of energy collectors, soaking up the stellar fury to power the disk's internal systems, its lighting rings, and its climate controls. It might house forges that use the sun's heat to smelt materials on a planetary scale, or laboratories conducting physics experiments impossible in milder zones. This is where the machinery of paradise is maintained, a roaring, brilliant engine room at the center of all creation. In stark contrast, the outer edge is a land of permanent twilight and deepening cold. As you travel farther from the central sun, its light grows dimmer, its warmth fades. At the very rim, you would look out over a landscape locked in an icy stillness. The sun is just a distant, bright point, no longer a source of heat but a lonely beacon in a black sky. Here, the controlled climate of the inner rings gives way to the natural chill of space. This frozen frontier could serve many purposes. It might be a zone for specialized research, where the near-absolute vacuum and cold are assets for astronomy or exotic physics. It could become a new kind of wilderness, home to life forms bio-engineered for resilience, thriving in crystalline forests under a dim sun. Or, in a more sobering thought, such a remote and harsh environment might be designated for heavy industry deemed too dangerous for the inner habitable rings or for secure facilities far from the population centers. These edge worlds act as a necessary counterpoint to the disk's central perfection. They are the frame around the painting, a constant physical reminder that even this seemingly infinite plane has limits. The journey from the lush, sun-drenched inner gardens to the silent, frozen outer dark would be a profound pilgrimage across a gradient of reality. It reinforces that the entire structure, for all its godlike scale, is still a finite thing, an island of carefully crafted order adrift in the cosmic dark. The edges are where the illusion of a natural world falls away completely, revealing the brutal, magnificent mechanics of the megastructure underneath. They are a reminder that paradise is not found, it is built, and it is maintained right up to its scorching and frozen frontiers. The disk's perfect, engineered geography conceals a deeper, more fundamental rift, one not of space but of time itself. To give its inhabitants a sense of down, the entire structure must spin. This rotation creates artificial gravity through centrifugal force, flinging objects outward toward the rim. But to generate Earth-like gravity at that staggering distance, the outer edge would need to be moving at a significant fraction of the speed of light. And when you approach those relativistic velocities, Einstein's laws take the stage, introducing a bizarre and inevitable consequence: time dilation. For the people living on that fast-moving rim, time itself would begin to slow down relative to their cousins living closer to the central, nearly stationary sun. A clock on the rim would tick just a little slower than an identical clock in the inner gardens. Over a single day, the difference would be negligible, a fraction of a second. But over the course of a year, it might amount to several minutes. Over a century, it could become years. Over millennia, the divergence becomes an unbridgeable chasm. This transforms the disk from a static map into a dynamic temporal landscape, where your physical address also dictates your speed through history. Two children born at the same moment, one in a city near the star and one in a settlement on the far rim, would not grow old together. The inner child would live a full life, see their grandchildren grow and pass away, while their rim-born counterpart from the perspective of the center would still be in the prime of their youth. The disk civilization would not experience a single, unified timeline, but a gradient of time, a temporal geography as real as its climate zones. This has staggering implications for every aspect of society. Think of communication. A historian at the disk center sends a radio message toward the rim, a simple greeting asking for news. That message, traveling at light speed, would still take years to cross the vast distance. But by the time it arrives, decades or even centuries of center time have passed. The historian who sent it is long gone, their civilization transformed. The reply, sent immediately from the rim, would take just as long to return, and due to time dilation, even more years would have passed for the center. A simple conversation could span generations, making real-time dialogue or shared cultural moments impossible. History itself would fracture. A major event, a revolution or a scientific discovery announced from the inner rings, would ripple outward in both space and time, arriving at different rim settlements at different points in their own local histories. Some regions might receive news of a war that, for them, ended centuries ago according to their own calendars. The very idea of a unified disk-wide culture evaporates. You could have neighboring rim societies, separated by a few thousand miles, that are actually centuries out of sync with each other because of slight differences in their rotational speed. They would be living in different eras, speaking evolved versions of a common language, with completely different frames of reference. The disk, designed as the ultimate cohesive home, would be doomed by physics to become a collection of islands drifting apart not in space, but in the river of time itself. This splintering of time forces a re-evaluation of ambition itself. When we dream of megastructures, we are not dreaming of a single idea, but of different answers to the ultimate question: what does a civilization truly need? The Alderson disk sits within a family of colossal concepts, each prioritizing a different fundamental resource. Compare it to its most famous cousin, the Dyson sphere. A Dyson sphere is a shell, or more realistically, a dense swarm of collectors, built around a star with one primary goal: to capture every single photon of its energy output. It is the ultimate power plant, a civilization's way of plugging directly into the stellar mains. But a Dyson sphere is not inherently a home. It is a machine for harvesting sunlight. Its vast interior surface is likely barren, airless, and scorching, engineered for efficiency, not for life. The Alderson disk makes a different trade. It sacrifices the spherical perfection and total energy capture of a Dyson concept for something else, an incomprehensible amount of living space. It is not about enclosing the star, but about using it as a fixed centerpiece for a flat, habitable plane. Energy is still vital, drawn from that central sun, but it is a means to an end. The end is real estate on a scale that makes every other habitat seem like a closet. Then there is the ring world made famous by author Larry Niven. This is a giant ribbon, a single strip of material forming a circle around its star, spinning to create gravity on its inner surface. It is undoubtedly a habitable megastructure, a band 1,000,000 miles wide with a circumference of hundreds of millions of miles. But compared to the Alderson disk, a ring world is a line, not a plane. It offers a vast but fundamentally one-dimensional strip of land. You can travel around it or along its width, but that is all. The disk, by contrast, offers a two-dimensional expanse. From the inner rim to the outer darkness, you can travel radially in any direction, across a continuous continent that has no parallel edge. The ring world is a cosmic racetrack, the disk is an endless plane. This distinction highlights the disk's core philosophy. It is the ultimate expression of maximizing habitable area. It represents a civilization that has moved beyond worrying about energy scarcity or even about efficient use of materials. Its priority is sheer, unbounded volume for growth, for experimentation, for life in all its possible forms. Where a Dyson sphere civilization asks, how can we harness all the power, and a ring world culture asks, how can we build a stable, circular habitat, an Alderson disk society asks a simpler, more profound question: what would we do if we had a flat universe of our own? It is a declaration that the ultimate resource is not energy but possibility, and that the greatest canvas for that possibility is not a sphere or a ring, but a disk with the surface area of a galaxy. A civilization born on the disk would see a universe crafted by literal hands. Their reality is not a sphere drifting through a void, but a fixed, flat plane under an unmoving sun. For them, the idea of a round world orbiting a star would sound like the most bizarre of fairy tales. Their entire frame of reference, from the ground beneath their feet to the sky above their heads, would point to a single, inescapable truth: the world is flat, and the sun is a divine prisoner at its heart. This is not a philosophical belief, but a daily, observable fact. Every myth, every creation story would be built upon this absolute geometry. Their great deity would not dwell in a distant heaven, but in the brilliant, terrifying well at the center of all things, a captive god whose light and warmth are gifts or perhaps demands for the people of the plane. The far side of the disk, arching over them to form the dome of the sky, would not be seen as another land, but as the firmament itself, the solid shell of creation. It might be depicted in their stories as the home of ancestral spirits, a gleaming, unreachable paradise where the gods walk upside down. The slow drift of lights across that curved sky, the cities of the opposite surface, could be interpreted as celestial processions or the watchful eyes of deities. Their science would begin not with astronomy, but with a profound struggle to map a universe that has no visible stars. Early thinkers would chart the precise angles of the sun's light, measure the strange, consistent pull toward the ground, and grapple with a horizon that does not curve. They might develop incredibly advanced flat plane geometry centuries before ever conceiving of a sphere. The concept of gravity pulling toward a center would be nonsensical. Down is simply down toward the infinite plate. A pioneer who journeyed to the fiery inner rim might be seen as a prophet who walked to the sun's prison, returning with tales of the forge of creation. An explorer who traveled outward, feeling the air grow colder and the light dimmer, would be venturing toward the land of eternal twilight, a place that might feature in their culture as the realm of the dead or a frozen wilderness where monsters dwell. This cultural lens turns the disk from an engineering project into a living thought experiment. It asks how deeply our environment writes our stories. Our own ancient myths are filled with chariots pulling the sun across the sky, with underworlds beneath the earth and heavens above the clouds, all reflecting a spherical world with a day-night cycle. On the disk, the epics would be different. They might tell of a time before the sun was bound, when chaos reigned across the formless plain. Their heroes might not sail over the edge of the world, but seek to reach the glittering wall of the sky or plead with the captive sun god for more warmth. Their greatest philosophical rift might not be about how the world began, but about what lies beyond the icy outer edge, or what purpose the architects who built their entire reality could have possibly had. This is the ultimate human layer on the megastructure, a reminder that even in a universe of staggering scale and perfect engineering, the minds that inhabit it will still weave meaning from what they see, crafting gods and legends from the only home they have ever known. The flat universe of a disk civilization would leave a glaring signature across the cosmos. If such structures are possible, and if a single species can build one, then where are they? This brings us back to one of astronomy's oldest and deepest puzzles, the Fermi paradox, but with a new and startling lens. The classic question asks why, in a galaxy so vast and old, we see no clear signs of other intelligent life. The construction of an Alderson disk would be anything but subtle. It would be a cosmic event of staggering violence and brilliance, visible from thousands of light years away. Think of the process, the deliberate, systematic dismantling of every planet, moon, and asteroid in a solar system. That is not a quiet endeavor. It would involve collisions on planetary scales, the flaring of immense energies as worlds are torn apart, and a brilliant, shifting infrared glow as the raw materials are heated, moved, and reformed. For centuries, perhaps millennia, that star system would shine like a beacon in the infrared spectrum, a telltale sign of industry operating on a scale that dwarfs nature itself. Our telescopes are perfectly capable of detecting such anomalous infrared signatures from distant stars. Yet, in all our surveys of the heavens, we have never seen anything that clearly matches the expected profile of a disk under construction. This profound silence is a clue that demands interpretation. One possibility is simple and humbling, that the Alderson disk, for all its conceptual grandeur, is forever confined to the realm of science fiction. The physical laws of our universe as we understand them may simply forbid it. The material strength, the energy requirements, the stabilization against time itself might be insurmountable barriers not just for us but for any intelligence, no matter how advanced. In this view, the disk is a beautiful dream, a thought experiment that highlights the ultimate limits of engineering, showing us a wall in nature that cannot be scaled. The absence of evidence is, in fact, evidence of impossibility. But there is another, even more mind-bending interpretation. Perhaps the disk is possible, but it represents a developmental stage that no civilization actually chooses to complete. Imagine a species on the cusp of such power, having mastered stellar energy and planetary engineering. At that moment of supreme capability, they might encounter a deeper truth about existence. The urge to build a physical monument, even one the size of a galaxy, might seem like a juvenile impulse compared to the frontiers that open within. Why spend millions of years rearranging atoms into a giant plate when you could be unraveling the nature of consciousness itself? The ultimate leap for a civilization may not be outward into space, but inward into substrate. They might choose to transfer their minds into vast digital landscapes, virtual realities of infinite complexity and variety, unshackled from the slow, stubborn laws of physics. Or they might transcend into forms of pure energy or information, existing in a state we cannot even perceive, woven into the fabric of space-time. In this scenario, the giant physical megastructure becomes a kind of cosmic teenager's dream, a phase you outgrow before you ever pour the foundation. The mature civilization leaves the world of stars and planets behind not by building bigger, but by becoming something else entirely, something that leaves no infrared signature for our telescopes to find. This transforms the silence of the universe from a lonely emptiness into a gallery of mysteries. The stars we see may not be lonely at all, but surrounded by intelligences that have moved on to realms we are only beginning to imagine. The Alderson disk, then, stands as a marker not of what is but of what could have been, a road not taken on the path to a destiny we have yet to understand. The peaceful, engineered perfection of the disk contains a terrifying vulnerability, for its greatest strength is also its greatest weakness. A conflict on this scale would be unlike any war in history, not fought over borders or resources, but over the fundamental systems that keep reality itself from unraveling. On a continent with no natural end, traditional conquest becomes meaningless. You cannot march an army across a territory wider than the orbit of Mars, and holding ground against a population of trillions is an exercise in futility. Instead, warfare would transform into a grim science of systemic sabotage, where the goal is not to defeat an enemy's soldiers, but to threaten the architecture of their world. The most terrifying weapons would not be bombs, but precision instruments designed to trigger cascading failures in the megastructure's delicate balance. A successful attack might target one of the colossal orbital shade rings. Disabling even a small section could condemn a continental region to decades of unending daylight or perpetual night, collapsing ecosystems and societies that depend on the rhythmic cycle. An assault on the gravitational stabilizers holding the central sun in place could be far worse, a nudge toward the inner rim that would slowly, inexorably drag the star into the disk's surface, a collision that would vaporize entire civilizations in a wave of stellar fire. The disk's interconnected nature means that a conflict in one zone could doom populations on the opposite face, people who may have no knowledge of or involvement in the dispute, simply because they share the same foundational bedrock. A weapon designed to punch through the crust could create a wound that vents atmosphere into space, or worse, severs a critical structural support, triggering a gravitational tremor felt across billions of miles. In such an environment, deterrence would take on a cosmic horror. The ultimate threat between rival powers would not be mutual destruction, but mutual suicide, with the lives of every being on the disk held hostage by the stability of the very ground they stand on. This transforms political conflict into a perpetual, high-stakes game of existential chicken, where the only winning move is not to play, for a single miscalculation could end not just a civilization, but the entire engineered world. The disk, built as a monument to life and growth, would therefore demand a level of political unity and conflict resolution beyond anything we can conceive, for the alternative is a battlefield where the first casualty is the universe they built together. Such a civilization would turn its endless plain into the ultimate canvas. With a surface area rivaling a galaxy, art is no longer confined to a frame on a wall or a statue in a square. It becomes geographical, a fundamental layer of the world itself. The scale allows for creations that are not merely observed, but experienced through travel and time. An artist could design a mural the size of a continent, its lines and colors so vast they only resolve into meaning when viewed from orbit or from a high-altitude craft. The journey to see it becomes a pilgrimage, with the artwork revealing itself slowly over days of travel, shifting perspective with every mile. Architecture would evolve not just by culture, but by region, with styles flowing and changing across millions of square miles like a slow cultural weather system. A single architectural movement might begin as a cluster of slender towers near the inner rim, then spread outward over centuries, adapting to the cooler climates and different light of the farther zones, its essence morphing until it becomes something entirely new 1,000 miles away. This is art measured in lifetimes and landscapes. Even sound could be reimagined. Composers might use the disk's own geology as their instrument, designing vast, resonant chambers within its million-mile thick crust. A single, sustained note could be played by tectonic plates shifted by gentle, controlled forces, sending a deep, subsonic hum through the foundation of the world, felt in the bones of every structure and being for thousands of miles. Or they could string cables from atmospheric towers hundreds of miles high to be played by the engineered winds, creating a permanent, shifting symphony across entire regions. The central, eternal sun itself would be the ultimate artistic subject and medium. Its unchanging position makes it a fixed point of reverence and inspiration. Temples and monuments would be aligned with its light in ways impossible on a turning planet, with rays designed to pierce specific doorways or illuminate sacred texts only on a certain day, a day that is, of course, every day. But more actively, the sun's light could be sculpted. Imagine orbital arrays of prisms and lenses positioned in the space between the disk faces, acting as a celestial light show. They could split the pure white sunlight into rainbows that sweep across continents, or project intricate, moving patterns of shadow and color onto the clouds and the distant arch of the opposite surface. The sky itself becomes a dynamic painting, a living gallery that changes with the will of its curators. In such a world, the line between art and environment dissolves. A forest is planted not just for ecology, but to form a living pattern visible from above. A mountain range is sculpted to catch the dawn light in a specific way. The entire disk becomes an ongoing, collaborative masterpiece, a testament to a civilization that has moved beyond creating objects to crafting the very sensory experience of reality. Here, beauty is not an addition to life, it is woven into the fabric of existence on a canvas as wide as the mind can dream. This sprawling engineered world offers something no natural planet ever could, a guarantee of survival. On a single planet, a species lives with a cosmic sword of Damocles hanging overhead. An asteroid impact, a supervolcanic eruption, a nearby star going supernova and bathing the world in deadly radiation. Any one of these events could erase a civilization in a geological blink. But on the Alderson disk, these existential threats are reduced to local tragedies. The scale itself becomes the ultimate shield. A gamma-ray burst, powerful enough to sterilize an entire solar system of planets, would strike the disk as a wave of energy hitting one side. It would scour a continent-sized area clean, a loss of unimaginable horror, yet that area would represent less than a fraction of a percent of the total habitable surface. The civilization on the opposite face of the disk, or even in distant zones on the same side, might not even notice the event beyond a strange atmospheric glow on their horizon. Their sun, fixed at the center, would be partially shielded by the disk's own immense bulk. Redundancy is not a feature they added, it is the foundational principle of their home. A disaster that would doom a planet merely creates a new frontier on the disk, a scarred zone that might be reclaimed centuries later or left as a memorial wilderness. This transforms the very psychology of a species. They are no longer precarious tenants on a fragile rock, but permanent residents in a fortress built to cosmic specifications. The commitment to build such a structure is therefore the ultimate act of long-term thinking. It is a declaration that the story of their people will not end with a random cosmic accident. It represents a dedication to legacy stretched across timeframes that dwarf human history, a promise to outlast not just ice ages and impacts, but potentially the very star that gives them light. When their sun finally begins to swell into a red giant at the end of its life, the civilization of the disk would have had billions of years to prepare. They could engineer a slow migration outward across the plane, ahead of the expanding stellar atmosphere, or perhaps they would have long since mastered stellar husbandry, finding ways to extend their sun's life or harvest its energy in a controlled final act. The disk is more than a habitat, it is a lifeboat for an entire species and its entire future, a single project designed to carry them safely across the dark, unpredictable ocean of deep time. But this cosmic lifeboat has a fundamental flaw, a problem of simple physics that no amount of material strength can solve. A star is not just a light in the sky, it is an ongoing thermonuclear explosion, and all that energy has to go somewhere. On a planet like Earth, the sunlight that isn't reflected simply warms the surface for a while before radiating back out into the cold vacuum of space. The planet is a tiny pebble in a vast dark room, and the heat easily escapes. The Alderson disk changes this equation completely. Its inner surface, that vast continent facing the sun, is not a small sphere. It is an enormous, continuous plane designed to absorb that light. It acts like a giant solar panel, but one with no off switch. Every second, it soaks up the entire energetic output of the star. Without a way to shed that heat, the disk would not simply become warm, it would cook. The temperature would rise and rise, turning the inner paradise into a molten hellscape, until the very materials of the structure began to soften and fail. Managing this thermodynamic budget is not a secondary concern. It is the central engineering hurdle that determines whether the disk is a habitat or a slow-motion oven. The structure must become its own universe-scale radiator. One theoretical solution uses the disk's own architecture. The dark side, the face turned away from the sun, is perpetually exposed to the deep freeze of space. This provides the perfect heat sink. Engineers could design a planetary-scale cooling system, with the disk's unimaginably thick crust acting as a conductive medium. Heat absorbed on the sunlit side would be pumped through vast internal networks of pipes or channels, moving like artificial blood through the body of the world, to be radiated away from the dark side into the void. This transforms the disk from a passive absorber into an active thermal engine, with the star's energy constantly flowing through it from the hot face to the cold face. The scale of this plumbing is almost comical to contemplate. The coolant flows would need to move volumes of material greater than all of Earth's oceans, circulating through channels wider than continents and deeper than planetary crusts. The pumps driving this system would require power drawn from the star itself, creating a loop where the sun's energy is used to stop the sun's energy from destroying the structure. Any failure, a blockage or a pump shut down in a critical sector, would lead to a local heat buildup that could warp the disk's geometry or trigger catastrophic material failure. This is the hidden, relentless work of maintaining paradise, a silent battle against thermodynamics fought in the heart of a world built by gods. It is a reminder that even the grandest visions of engineering must bow to the most basic laws of physics, where the brilliant light of creation must always be balanced by a cold, dark breath into the endless night. The silent machinery eventually stops. For all its grandeur, the disk is not eternal. Its builders, the minds that conceived and forged this plane, could one day vanish. Perhaps they transcended into forms we cannot perceive, or perhaps they simply faded away, their civilization ending not with a bang, but with the last maintenance drone powering down. What remains is not a dead world, but a frozen monument, a clockwork universe whose gears have finally stilled. The central sun still burns, but now its light falls on empty cities and silent forests. The orbital shade rings hang motionless, casting permanent shadows across continents. The great heat pumps fall silent, and temperatures begin their slow, irrevocable drift. The inner rim grows unbearably hot, the outer edge sinks into absolute cold, and only a narrowing band in between retains a memory of the paradise that was. The disk becomes a tomb of impossible scale, a museum of a godlike culture, waiting in the dark for visitors who may never come. Those visitors, if they ever arrive, would face the ultimate archaeological puzzle. Imagine explorers from another star navigating the void between suns. They would not find a planet to land on, but an artificial plane, a flat geometric shape blotting out its own star. Their first surveys would reveal a structure so vast it defies their instruments, a single artifact with more surface area than their home galaxy's entire collection of worlds. Landing on its surface, they would step into a silence deeper than any planetary wilderness. They would not dig for ruins, they would walk among them. Their excavation sites would be derelict cities whose sprawl eclipses whole planets, metropolises of crystalline spires and geometric canyons, empty for 1,000,000 years. They would find libraries where the walls themselves are data storage, and factories where the machinery is sized to reshape mountains. Every artifact is continental, every clue is geological. A crack in the ground is not an earthquake fault, but the remnant of a structural failure that vaporized a sea. A discoloration in the atmosphere, visible from space, might be the eternal stain of a final, forgotten war. Piecing together the history of the builders would require a new kind of science. On a planet, archaeologists read time in layers, digging down through strata of soil and civilization. Here, time is written in geography. The story is laid out flat across the endless plain. The oldest districts might cluster near the stable inner zones, with newer expansions radiating outward like rings on a tree. A sudden end to construction at a certain radius could mark the moment the builders' expansion halted, a cultural freeze frame. They would find art not in galleries, but in the purposeful shape of river valleys and the patterned colors of engineered forests, landscapes designed to be viewed from the sky. Their greatest challenge would be deciphering the technology itself. They would study the inert stabilization rings, trying to understand the physics that held a star in a perfect cage. They would map the ossified coolant channels, giant arteries in the world's crust, to deduce how the builders managed thermodynamics on a stellar scale. Each broken piece of machinery, each silent power node, is a clue to a science that treated natural law as a suggestion. The ultimate mystery they would confront is not how the disk was built, but why its caretakers left. The evidence would be everywhere and yet utterly opaque. Were there signs of a planned departure, with systems shut down in an orderly sequence? Or does the evidence point to a sudden vanishing, with meals left on tables and lights still glowing in some sectors, preserved by backup power for eons? The disk does not offer an obituary, it offers a frozen moment. The culture's entire existence, from its earliest ambitions to its final days, is smeared across this impossible canvas, a biography written in continents and silence. For the alien archaeologists, this would be more than a dig. It is a confrontation with a scale of ambition that might dwarf their own. They would be studying a civilization that answered the question of survival by building a universe of their own, only to apparently walk away from it. This silent, monolithic artifact would become the greatest question they ever found, a monument that does not celebrate a victory, but poses a single, haunting riddle about the destiny of intelligence itself. The silent monument of a dead disk reveals a final, haunting truth about the builders. But what of the living minds that called such a place home? Our own psychology is a product of a spherical world, a delicate negotiation with a curved horizon and a moving sun. On the Alderson disk, those fundamental references vanish, replaced by a geography that would rewrite the human mind from the ground up. The most immediate shock would be the loss of the horizon itself. On Earth, the horizon is a promise and a limit, a gentle curve that tells us the world is round and our view is finite. On the disk, depending on atmospheric clarity, that line might simply not exist. With a surface so flat and vast, the ground could appear to stretch onward forever, merging with a haze of distant atmosphere until land and sky become an indistinguishable, endless plain. There is no comforting edge to the world, only an infinite continuation. For a mind evolved to navigate bounded landscapes, this could trigger a form of agoraphobia of cosmic proportions, a visceral terror of the unlimited. Conversely, if the disk's own slight curvature over such immense distances became visible, the effect would be equally strange. The land would appear to curve upward in all directions, creating the sensation of standing at the bottom of a shallow continental bowl, with the world rising up to meet the sky. Your entire visual field would be ground, a constant, looming pressure from the periphery. this fundamental shift in spatial awareness would demand new instincts. Navigation could not rely on landmarks that eventually dip below a curve, but on features that simply dwindle into the haze. The very concept of over there loses meaning when there is 1,000 miles of identical terrain away. Your brain would have to recalibrate its sense of scale to the truly continental, where a journey of a lifetime might not even cover a visible fraction of your local zone. This new psychology would be one of profound rootedness or profound disorientation, a mind either perfectly adapted to the infinite plane or forever feeling adrift on a sea of solid ground. This geographical shift is paired with a temporal one written in light. Our bodies are tuned to a rhythm, the reliable pulse of day and night governed by a turning planet. On the disk under the unmoving sun, that rhythm is absent. The eternal noon, or the engineered day-night cycle from the orbital shades, is a metronome set by engineers, not by nature. For biology evolved on a spinning world, this could be deeply disruptive. Without the natural cue of fading light, our internal clocks, our circadian rhythms, might drift or break down, affecting sleep, hormone regulation, and mood. The civilization would likely need to engineer this rhythm at a personal level, with artificial lighting in homes and workplaces meticulously programmed to simulate a sunset, or perhaps with widespread genetic or technological adaptation to a new, static relationship with light. The very idea of night becomes a cultural artifact, a shared story of a time when the world turned, rather than a daily experience. This could lead to a society with a completely different relationship to time itself, less cyclical and more linear, where activities are not dictated by the sun's position but by social or industrial schedules. The psychological anchor of the day's journey, from dawn's hope to evening's rest, is replaced by something else, perhaps a focus on task completion or artistic cycles independent of the sky. Living inside such a clearly architected reality would impose its own unique weight. On one hand, it could foster a sense of security so deep it becomes a background constant. There are no natural disasters here, no unpredictable storms or tectonic surprises. Every mountain, every river, every breeze exists by design. This is a universe of answers where every why ultimately traces back to the will of the builders. For many, this could be profoundly comforting, a removal of cosmic uncertainty. You are not a speck on a random rock, but a resident in a carefully crafted habitat, your existence a validated part of a grand, intentional plan. Yet, that same clarity can twist into a feeling of terrifying insignificance. If everything is designed, then are you. Your thoughts, your culture, your very path in life could feel preordained, a predictable outcome in a machine of world-sized clockwork. The awe inspired by a natural universe of mystery is replaced by the awe of an engineering specification of unimaginable complexity. You are living inside someone else's masterpiece, and that can be a lonely realization. The search for meaning might turn inward, focusing on personal experience and art within the canvas, or it might turn outward toward the one remaining mystery, the question of what lies beyond the disk's engineered edges. The psyche of the disk dweller is thus pulled in two directions, between the comfort of an explained universe and the quiet dread of being a character in a story whose authors have long since left the page. This is the ultimate human consequence of the megastructure, not written in its material strength or energy budgets, but in the silent rewiring of consciousness itself, crafting a new kind of mind for a world that never knew a horizon. The scale of the disk places its builders in a specific category of cosmic achievement, one that measures a civilization not by its art or philosophy, but by its raw energy budget. This is the Kardashev scale, a simple but profound framework for classifying intelligent life. A Type 1 civilization has mastered its home planet, harnessing all the energy that reaches it from its star. We are still approaching this level, A Type 2 civilization has mastered its star itself, capturing its total luminous output. The builders of an Alderson disk would almost certainly be a solid Type 2. Their entire world is a direct expression of that mastery, a structure that not only uses the star's energy but is fundamentally arranged around it, with the sun as a fixed component in their engineered reality. They are not just living off the star, they have plugged their entire civilization directly into its furnace, using that power to maintain a plane of existence larger than a galaxy. This is the ultimate expression of a Type 2 society, a culture that has turned its solar system from a collection of objects into a single, integrated machine for life. But the scale presents a fascinating fork in the road. Does the disk represent a final, glorious destination, or is it merely a stepping stone to something even grander? The next step on the Kardashev scale is Type 3, a civilization that harnesses the energy output of an entire galaxy. With the disk's unimaginable resources and population base, the leap to Type 3 becomes a tangible possibility. Think of the momentum such a society would possess. A single disk could house quintillions of individuals, a population so vast that even a tiny fraction dedicated to exploration and engineering could launch interstellar missions on an industrial scale. They would have the material wealth of disassembled planets, the energy of a harnessed star, and the intellectual capital of a unified, galaxy-spanning culture born from that single, vast plane. The disk could become the ultimate launchpad, a factory for von Neumann probes and generation ships, sending waves of expansion into the galactic void. In this view, the disk is not a cage, but a cradle, a stable, abundant home base from which a civilization graduates to seed the stars, achieving Type 3 status not by necessity, but by the sheer, overflowing momentum of its own success. There is, however, a compelling counter-argument. The disk could just as easily become the ultimate cul-de-sac. The project of building and maintaining a perfect, artificial universe is so all-consuming, so intellectually and culturally absorbing, that it might turn a civilization permanently inward. Why venture into the cold, dangerous, and empty vastness between stars when you have already constructed a paradise of infinite complexity right here? Every mystery, every frontier could be invented and explored within the disk's own parameters. You could simulate 1,000,000 alien galaxies in virtual realms, or bioengineer life forms more exotic than anything evolution could produce on a random planet. The drive to explore the natural universe might simply fade, replaced by the deeper drive to perfect the crafted one. The outside cosmos, with its harsh laws and random dangers, could come to be seen as a pointless, chaotic wilderness, while the disk represents the pinnacle of order, beauty, and safety. In this scenario, achieving Type 2 mastery becomes not a launchpad, but a peak. The civilization settles into a kind of eternal, sublime stewardship, focusing on the endless artistic and social possibilities of their own creation, leaving the natural galaxy to its silent, unobserved dance. They become gardeners of a single, perfect world, having traded the hunger for the stars for the contentment of a universe made by hand. This is the profound choice the disk represents. It is either the engine of galactic expansion or the masterpiece that ends the need for it, a monument to ambition that could either propel a species to godlike status across the stars or inspire them to become gods of a single, magnificent, self-contained creation. This philosophical choice carries a staggering moral weight. The breathtaking vision of a disk comes with a quiet, sobering prerequisite: the complete dismantling of its home solar system. To build this single, perfect plane, a civilization would need to take apart every planet, every moon, and every wandering comet. Mars, with its silent valleys, would be ground into aggregate. The swirling, stormy majesty of Jupiter would be siphoned for its hydrogen and helium. The icy rings of Saturn, a natural sculpture of cosmic beauty, would be melted down for their water and minerals. This is not mining, it is cosmic recycling on the ultimate scale, turning the diverse, ancient bodies of a star system into uniform building blocks. The ethical question becomes immediate and profound. Does intelligence, once it reaches a certain level of power, grant the right to erase the natural history of an entire planetary family? We cherish the Grand Canyon for its slow, patient carving by water, and we protect ancient forests for their complex, evolved ecosystems. But what is the value of a gas giant, a world that never knew life but has circled its star for billions of years, a unique testament to the chaotic, beautiful process of cosmic formation? Dismantling it for raw materials treats it not as a world with its own story, but as an inert stockpile of atoms, a resource to be spent. This frames the disk as the ultimate expression of a utilitarian view of the universe, where the value of natural objects lies solely in their usefulness for a greater, designed purpose. The debate deepens further if we consider the faint, terrifying possibility of life elsewhere in that same system. A simple microbial colony in the subsurface ocean of an icy moon, or a unique biochemistry in the clouds of a gas giant, would represent a universe of discovery, a second, independent genesis of life. The construction of a disk requiring the sterilization and processing of all orbiting bodies would almost certainly erase such life without a second thought. The ethical calculus then becomes almost unbearably difficult. Does the potential to create a habitat for trillions of your own kind justify the certain destruction of another, alien form of existence, even a simple one? This is environmental ethics expanded to a galactic scale, asking not just about our duty to our own planet, but our duty to the natural cosmic order itself. It asks whether the universe is a garden we are meant to tend and preserve in its wild state, or a quarry we are meant to shape into our own image. The civilization that chooses to build a disk has implicitly answered that question. They have decided that engineered perfection, a universe of guaranteed stability and abundance, is worth the price of a natural one with all its randomness, danger, and untouched beauty. This is not a technical decision, it is a valued judgment of monumental proportions, a declaration that their vision for existence outweighs the preservation of what came before. It reflects a belief that the highest purpose of matter is to support conscious life, and that the most noble form of nature is the kind built by a mindful creator. The disk, therefore, stands as more than a megastructure. It is a physical manifesto, a statement carved across light years that for its builders, creation is a higher virtue than preservation, and that the destiny of intelligence is to become the author, not merely the reader, of the story of the stars. The Alderson disk ultimately serves as a profound mirror held up to our own civilization. It reflects not just what we might build, but who we might become when freed from the constraints of a single, fragile world. This staggering concept stretches our understanding of engineering to its absolute breaking point, demanding materials that defy nature and energies that dwarf stars. It asks us to consider the ultimate purpose of intelligence, whether its destiny lies in spreading across the galaxy or in crafting a single, perfect universe of its own design. More than a blueprint for a megastructure, it is a philosophical tool, challenging every assumption we hold about habitat, society, and our relationship with the cosmos. While the physics may forever confine it to the realm of thought experiments, its true power lies in this expansion of our imagination. By contemplating a disk with the surface area of a galaxy, we are forced to think on a timescale of eons and a moral scale that encompasses entire solar systems. It makes our current planetary struggles feel both infinitesimally small and vitally important, a necessary first step on a ladder whose highest rungs touch the architecture of reality itself. This exploration reminds us that the future is not a single path, but a spectrum of possibilities, from the quiet stewardship of a planet to the godlike ambition of rearranging stars. Each vision carries its own beauty, its own cost, and its own story about the value of life and the meaning of home. The disk invites us to look up at the night sky not just with wonder, but with a new question: not what is out there, but what could we, or something like us, someday choose to make of it all. If this journey to the edges of possibility sparked your curiosity, consider subscribing for more deep dives into the future of technology. And we would love to hear your perspective. Would you ever want to live on an Alderson disk? Share your thoughts in the comments below.